Hello everyone. I've come with another video today. This time we want to talk about resistors. Last time we were talking about a transistor. Sorry, we were talking about a diode, sorry. So this time I just want to talk about this resistor here. As you can see, this is a variable resistor. It is not a fixed resistor. It is a variable resistor, okay? It's actually a potentiometer, right? So what I'm going to be doing then, I just want to show you the effect on this load, which is our motor. And I've also put a bulb just to help, the visuals. So let's get started. We want to check let's check the voltage source. So we have almost 12 volts there, okay? So that's good. If I close my switch, okay, let me go that way. If I close my switch, you can hear the motor is running. You see that? You see? It is running. And the light is on too. All right? So if we were to check our voltage, let's come and check our permanent live. Yep, this is connected directly through the red wire, right straight to the battery. Our permanent live is okay. Our live to the load, that's after the relay terminal pin 87, okay, through the resistor right into the motor. That's fine. Then we come right here before the resistor, feeding the resistor, okay? We have the same power, same voltage, slightly dropped, of course, through the switch and other things and the relay. So when we come here, we have dropped through the resistor. We have now, our voltage has dropped. So what I want you to see is the effect or the impact of increasing resistance, okay? So if I start turning, we have got 6 volts there. If I start turning the knob, you see the knob is inside. Let me turn it clockwise, okay? When I'm turning the knob clockwise, I'm increasing resistance. So we want to see the impact of that on this voltage, okay? Does it affect this output voltage from the resistor? So there we go. You can even tell the sound. Look at the bulb as well. You can tell the sound, it has come down. So there is now less, the voltage has gone down from about 6, now it's about 4.8. So if I continue increasing resistance, listen to that. The motor is turning very, very slowly. If I were to continue, now we are left with 0.7 volts, okay? If I were to give maximum 0.1, that's what we have, all right? And that is not enough to drive that motor, even to turn that bulb on, all right? So this is what resistance, a variable resistor, does. It allows you to pick the amount of current that you want to flow in the circuit, okay? You can pick this, you can determine the speed of that. It's like when you put your foot on the accelerator pedal of a car. You know, you determine the speed that you want by the pressure that you put on. That's a variable resistor on its own. Okay, it's a potentiometer. Your throttle position sensor is a potentiometer. So that's what it does. So here, when we turn anti-clockwise, we reduce resistance. The moment we start to press going up, our resistance is going up, and then the motor does not run. So here's what I want to do. I want to prove that this resistance is variable. Okay, let me go to, I can come here and there. Okay, I just want to check resistance. So we've got the resistance that we are reading now is 0.2664 kilo ohms. Take that into account. So roughly, which means we've got 266 ohms. That's what it means. All right. And if that goes with what is written on the resistor here. Can you zoom, please? That's what is written on the resistor. We've got 250. You know, there's plus or minus tolerance there. So that's why we are reading 266. So 266, that's at that, we can't get the motor to run. Okay. But if I am to come the other road, okay, we only have 10 ohms. Okay, that's why you find if I press the switch, the motor runs fast. Okay, because we only have 10 ohms. That's all we have. Okay, we have 10 ohms. There's not much. So a variable resistor changes its resistance depending on what you wish, what you want. Okay, so at the moment, the resistance is 122 ohms. Okay, at that, I can't run the motor at 122 ohms. Okay, and there is 57 ohms. All right, that's 57 ohms. I can't run the motor. Right, let me go to 35, 31. The light is beginning to flicker. Okay, it's coming on. So if I go, let's say to 15, 14, roughly 15 ohms, okay? The light is turning on, and then we go to, let's go maybe to 12, okay? Now, we can run, our motor begins to run, that's about 11.5. So we are able to, okay, if I drop it to 10, when our voltage is improved. Okay, so there you go. That's what a variable resistor does. It allows you to set the point of that determines the speed of the motor that you want. Okay, you can actually determine that by moving this dial. If I want to reduce it, if I could check RPMs here, that would even be better, but I can't. So, but you can tell by just by listening that I've changed my RPMs here. Okay. I have increased. we need to be careful to make a distinction between a rheostat and a potentiometer, because the two will appear, almost the same. A rheostat will reduce the current that is flowing in the system, yet a potentiometer, deals with, with voltage. But they are both variable resistors. That's the point I'm trying to make. Okay, they are both variable resistors. Just to go on the symbol side, just to show the different symbols for the potentiometer. So these were the old ones. The top ones are the old ones. These are the new symbols. So whenever you have, a symbol of a resistor with a striking arrow, then you know that it is a variable resistor. It's a potential. It's a potentiometer. The same here. So what actually it's showing us here, it shows that it has got three terminals with 1, 2, 3, 1, 2, 3, okay? Which is the same as well this side. So we have mainly, two types of resistors. We've got fixed and variable ones. And yet the purpose of the resistor in a circuit would be, to direct current. So you remember, current follows the path of least resistance. So you can actually direct current where you want it to go, or you can actually use a resistor to control current, okay? Those are some of the things that you can use the resistor for. They are more, of course, like changing currents, produce changing voltages, like in a voltage amplifier, okay? What I want to do maybe before would be to, or maybe let me talk about the three terminals. So we have the 5-volt reference, okay, and then we have got the ground, okay, and this is our resistor. So the main purpose of a potentiometer is to vary the voltage in a circuit. That's all that it does. It is to vary voltage. It is unlike a rheostat, which increases resistance. It changes resistance. Okay, this one varies voltage. That's the purpose of a potentiometer. So 5 volts through, and current flows to the ground. Okay, so this is our ground side. This is our 5-volt reference. So as this wiper moves along, okay, as it moves along, resistance is changing. Sorry, the voltage is dropping. Okay, the voltage is dropping as it moves along, right? So from here, when it's sitting right here at B, we have got reference voltage, all right? But the moment it comes, to C, we have the lowest voltage, 1 volt or less than 1 volt. Okay, so the purpose of a potentiometer is to vary the voltage. The difference of a potentiometer with a rheostat is that a potentiometer has got 3 legs. Okay, I can show you here. Okay, there is 1, 2, and you've got the third one. So 1, 2, 3. That's 1, 2, and 3. But with a rheostat, it has only 2. Okay, it will have a power and then it will have a signal. So it has got only 2. So having said that, maybe let me add something here when it comes to the fixed resistor. You can actually, figure out, okay? You can actually look at these colors, and then you can determine the value of the resistor. And also, you can also determine the tolerance, because that fourth band there is for the tolerance. Okay, it's either gold or silver. It is either gold or it is silver. That fourth band there, right? When it is gold, it will be 5% tolerance, and when it is silver, it is 10% tolerance. And if there is no color at all on the fourth band, then it is 20%. That's what we have here. 5% is gold, 10% is silver, 20% there is no color. So this first band here, all right, maybe I need to come on the scale here on the value code. So we have got numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we've got 0 is black, 1 is brown, 2 is red, 3 is orange, 4 is yellow, 5 is green, blue is 6, violet is 7, gray is 8, and then white is number 9. So we've got 10, a scale of 10. So in this case here, if you come here, you have got yellow, and then you've got red, and then you've got orange, and then you've got silver. So for yellow, we said yellow is number 4. So because it's the first band, we just put number 4 down. Okay, we just take the number as it is and we put 4 down because yellow is 4. And then red is 2 as well. You take the second band as it is. So red, it is 2. So we just come and put 2 down here. But this is where you really need to take, to be aware of. Take notice of this third band, okay? These are the number of zeros, okay? The third band is the number of zeros. So we have got orange. Orange is number 3. So all that we do, we put 1, 2, 3 zeros. So now when we read this number, it is 42,000 ohms, plus or minus the tolerance 10, okay? Plus or minus tolerance of 10, okay? So because why am I saying 10%? We have silver here, which we said silver would be 10% tolerance. But that's how you determine the, those colors. Unfortunately, there isn't one here, but let me see. Yeah. You see, these are the colors that I'm talking about. All right. Let me see. Let's focus and see. Those are the colors that we're talking about. So we start reading from this side here, because you can see the gold there. That's our fourth band. That's our tolerance. Okay. So maybe let me put it this way, so that we can look at it correctly. Okay. You see that? So what we want to do here, let's look at these colors closely. Just let me take it. Yeah, somewhere there. So we've got a brown, a black, and a red, right? So for a brown, when we come to our scale, is 1. So we put 1. And then a black is 0. We put 0. And then the third one, which is the number of zeros, is red. So red is 2 zeros. So this is 1000 ohm, which is 1 kilo ohm. Okay. If we come this side, bingo. Right? We are on the money. So you can use, of course, the tolerance. If you notice, let's see, right? Our tolerance, that's gold. So that will be plus or minus 5%. Okay. So it will be plus or minus 5%. So that is how you read, the value of a resistor, especially a fixed resistor. That's exactly how you deal with it. Right, that's the end of our lesson on resistors. Yes, there is quite a lot that we can say, but I thought I should just touch bits and pieces. Next time I'll bring the calculations. I just want to separate them from, I don't want to make it too long a video. I'll bring the calculations to show you what you do with resistors in parallel and what you do with resistors in series. So if we can take another short video on that, then we can conclude our lesson on resistors. I think that's the only part that is left. So thank you very much. Remember to subscribe and click the notification bell. If you have any questions, please send me your comments and we'll be glad to come back to you. Thank you.